Okay. So this is the first parameter that we're going to discuss. And for that, what we need, but basically we have to draw the pH graph. So in the last lecture, I discussed with you guys about the pH graph, pressure and enthalpy graph for the VCRS system. Okay. Now, all of you know that we have different four processes in the VCRS system. What are these processes? We have 1 to 2, that is called isentropic compression. What is 2 to 3? Constant pressure or temperature heat rejection in the condenser. What is 3 to 4? Anyone? What is 3 to 4? What is 3 to 4? Any idea? What is 3 to 4 in the VCRS system?
Isenthalpic process.
Yes. So expansion device comes into play. And what is 4 to 1? 4 to 1 basically is the work that we are doing in the evaporator. So all of you are aware of this particular thing. Okay. Now, in this pH graph, you guys look 1 to 2, I have to show the isentropic compression process. Let us suppose I say I'm starting at this point. This is my point number 1. And I'm doing isentropic compression at this point from 1 to 2. So this is my point number 1. This is my point number 2. Clear? Now from 2 to 3, there will be condensation. During that process, the pressure remains constant inside the curve as well as the outside also. This is 2 to 3. Here, 3 to 4 is isenthalpic expansion. So enthalpy remains constant. So 3 to 1 is going to be a vertical line. And this is 4 to 1, the last process. Is it clear to all of you? Anyone? Any doubt? Okay. So this is the basic cycle that we have been discussing in the pH graph from the last one lecture. Now, what is new about it? He's saying that if I decrease the suction pressure, if I decrease the suction pressure, what is going to be the effect of this thing on the COP of the VCRS system? It will increase, or it will decrease, or it will remain constant. That is the question he's asking. So he's saying this is what will be the effect of this decrease in suction pressure on the COP of the system. Now this is the ideal cycle that we have 1, 2, 3, 4. Now if you guys look at it, I have to find the value of COP of it. What is the value of COP? COP is refrigeration effect, all of you know, upon the work input that we have. Now what is the value of refrigeration effect? It is from 4 to 1, the evaporator. So in terms of enthalpy, it will be what? It will be H1 minus H4. Upon what is the work input? We are compressing it from 1 to 2. So the value will be H2 minus H1 in terms of enthalpy. Okay. Now what is the next step now? If we decrease or increase the pressure, what is going to be the effect of this thing on the COP? Okay. Now he says we are decreasing suction pressure. So at point 1, what is point 1? Point 1 represents the suction pressure. He says if I decrease it, so let us suppose if I decrease it, I'm saying this is not my point 1. Clear? I say my point number 1 lies below it. Let us suppose I'm starting from this point. Clear? So this is my 1 dash point now, the new point after decreasing it. So again, I have to attain the same thing. So I will now compress it from 1 to 2. But now when we will compress it isentropically in the compressor, this is how it basically goes. So this will be your new point. 2 dash. 2 dash to 3 will remain the same. Now when it will drop now from 3 to 4, it will drop to this point. This basically will be known as your 4 dash, and this 4 dash will join now the point 1 dash from where we are starting. Okay, so what I'm showing is that we are decreasing the pressure, suction pressure. After that, initially the process was 1 to 2 to 3 to 4. Now what is the new pressure? It is 1 dash, the starting point, 2 dash, 3 remains the same, and 4 dash, new point. This is the process that we are getting when we decrease the suction pressure. Clear? Now, if I have to find the value of COP of this new system in which we have decreased the suction pressure, what is the COP of it? Now, the refrigeration effect is basically from what? It is basically from 4 dash to 1 dash. So it will be H1 dash minus H4 dash upon what is the work input? Initially it is 2 minus 1. Now it will be H2 dash minus H1 dash. Clear? So these are the two COP formulas. Now you can look at this value, that at this value, the value of H4 will be equal to H4 dash because they are on the same point. So we can say, or we can write that H1 dash minus H4 dash will be equal to H4. So we can write H4 only over H2 dash minus H1 dash. Now, just try to compare the refrigeration effect of both the systems and try to compare the work input of both the systems. So if I write H1 minus H4 on one side and H1 dash minus H4 dash or H4 on the other side, which will have higher value? Please tell me, which will have higher value? Refrigeration effect will be same in both, or it will be greater in one and lower in one? Anyone? If you guys just look at the graph, this is the value of 1 dash. This is my 1 dash and this is my 1. So the value of enthalpy at point 1 dash will be H1 dash. And the value of enthalpy at point 1 will be H1. So obviously we can say that the value of H1 is more as compared to H1 dash. Whereas the value of H4 and 4 dash both are same. So which will have the higher value? H1 minus H4 or H1 dash minus H4 dash? Anyone? Obviously, if H1 is more, then this value is more than H1 dash minus H4 dash.
Sir.
Yes, please.
Sir.
Yes, yes, बोलिए बेटा.
Sir, आवाज लैग कर रही है आपकी.
Okay, अभी भी लैग कर रही है?
नहीं सर, अभी नहीं कर रही, बीच में कर रही है.
Okay, okay, no issue. So this one will have the more value as compared to the refrigeration effect which was produced in the later cycle. So what we can say that refrigeration effect after decreasing the suction pressure will increase or decrease? Please tell me. Refrigeration effect after decreasing suction pressure increase कर रहा है, decrease कर रहा है? Anyone? Anyone guys?
Sir, decrease हो रहा है.
It is decreasing. Okay. Now the next point, compare the work input. So we will have H2 dash minus H1 dash on one side and H2 minus H1 on the other side. Which one will have more value? To compress the refrigerant from 1 to 2 or to compress the refrigerant from 1 dash 2 dash, which will require more work input from the outside? Which will require more work input, 1 to 2 or 1 dash to 2 dash? It is clear, obviously, beta. From the length of it, you can say that 1 dash to 2 dash जो आपको वर्क इनपुट रिक्वायर्ड है वो क्या है, ज्यादा है. सो वर्क इनपुट की जो वैल्यू है वो क्या हो रही है, इंक्रीज हो रही है. So now if I look at the value of COP of the cycle after reducing the suction pressure, रेफ्रिजरेशन इफेक्ट आपका डिक्रीज कर रहा है और आपकी CO इनपुट जो है, वर्क इनपुट है, वो क्या कर रहा है, इंक्रीज कर रहा है. तो ओवरऑल आपकी जो COP की वैल्यू है वो क्या करेगी, इंक्रीज करेगी, डिक्रीज करेगी, इट विल डिक्रीज. So now if somebody asks that what is the effect of suction pressure, decreasing the suction pressure on the COP of the system, you will say that if we decrease the suction pressure, the COP of the system will also decrease. This is a really very important question from the gate point of view. Gate में especially different parameters के क्या effect है on the COP of the system, ये questions हर बार पूछे जाते हैं. Suction pressure, discharge pressure, superheating, subcooling, इन सबका क्या इफेक्ट है on the COP of the system. So they are very tricky. If you are aware of the graph, you can easily explain the concept of it. अगर आप ग्राफ से अवेयर नहीं हो, then they are slightly tricky. Clear? So this is the concept of it. Is it clear to all of you? Again, this pressure and enthalpy graph comes into the picture. Really very important. Pressure and enthalpy graph. On the basis of that only, we are going to compare it. Okay. So now, ideally, if I draw the graph, how it looks like? It looks like point 1 over here. This is my point number 2. A line horizontal. This is point number 3. Isenthalpic expansion, so enthalpy remains constant. A vertical line, point number 4. Evaporation, the pressure remains constant. This is how the actual graph that we are drawing looks like. So the process now that we're having is what? It is 1, 2, 3, and 4. Now he says that if we increase the delivery pressure, what will be the effect of that thing on the COP? Now, what is the delivery pressure? As I told you guys, point 1 represents the suction pressure and point 2 represents the discharge pressure or the delivery pressure, you can say.
Sir, condenser में?
Yes, no, it is in the compressor only. 1 to 2 is isentropic compression. So at the pressure, when it enters into the compressor, that is called suction pressure. And after the compression of it, when it comes out from it, that is called delivery pressure. Clear?
Okay.
So if we increase the delivery pressure, it means he is basically talking about the value of 2. He says that the value of 2 is increased. So what will happen? If the value of 2 is increased, let us suppose now 2 is not at this point, 2 is entering at this point and ending at this point. So we have increased the value of it from 2 to 2 dash. Now if it is increased, the next process remains the same. Condensation process in the condenser. 2. This was basically ideal 3. Now this point becomes 3 dash. The new point of 3 on the curve, this line. Okay, and this will be the vertical line of isenthalpic expansion, and this will be your new point H4 dash. So we are starting from point 1. This is my point 1 to 2 to 3 to 4. Now, if I increase the delivery pressure, what is the new process? It becomes 1 to 2 dash to 3 dash 4 dash. This is the new process that we are having after increasing the delivery pressure. Now, if you guys just look at it, what is the COP of the system originally? When we consider the point 1, 2, 3, 4, It is refrigeration effect, that is H1 minus H4 upon the work input, that is H2 minus H1. Now, what is the COP of this new system? From 1 to 2 dash to 3 dash to 4 dash, it will be H1 minus H4 dash over work input will be H2 dash minus H1. Okay. Now, if we compare the both, first of all, the refrigeration effect. H1 minus H4 will be compared with H1 minus H4 dash. Okay. So if we compare these both values, which one will have the more value? H1 remains the same for both the points. Let us suppose, I will just give you an example. Let us suppose H1 is 10 and H4 initially is 3. So H1 minus H4 will be 7. But now if we look at the value of H4 dash, we know that its value is more than 4. Let us suppose it is 4. Clear? H4 3 था, तो 4 dash की वैल्यू से क्या ज्यादा आ रही है, तो क्या मान ली उसकी वैल्यू क्या आ रही है 4. नाउ H1 minus H4 dash की वैल्यू कितनी आ जाएगी यहाँ पे 10 minus 4, वो कितनी आ जाएगी 6. तो मींस अभी आपकी जो वैल्यू आई रेफ्रिजरेशन की वो क्या आई, कम आई एज कंपेयर टू इनिशियल वैल्यू जो कितनी थी 7 थी. जस्ट गिविंग यू एग्जांपल जस्ट फॉर कंपैरिजन पर्पस. सो इट मींस H1 minus H4 की जो वैल्यू थी वो क्या थी, ज्यादा थी एज कंपेयर टू H1 minus H4. इट मींस ओवरऑल जो आपका रेफ्रिजरेशन इफेक्ट है अभी वो क्या हुआ, डिक्रीज हुआ बाय इंक्रीजिंग द डिलीवरी प्रेशर. नाउ if you just look at the second part of it, that is the work input, it will be H2 minus H1 on one side and H2 dash minus H1 on the other side. So from the picture itself, it is clear. If we need more pressure at the delivery of this compressor, then we need more work input to produce so. So if more work input is required, it means the work input in this case required will be more as compared to the initial one. So the value of work input is increasing. So if you just look at the value of COP, COP is what? It is refrigeration effect upon the work input. So refrigeration effect is decreasing, work input is increasing. So overall the value of COP will do what? It will decrease just like the last case. So if somebody asks what is the effect of increase in the delivery pressure on the VCRS system COP, we will say the value of COP will decrease if we increase the delivery pressure. Clear? I hope it is clear to all of you. It is a really very important concept of the VCRS system. Okay. So now you guys just look at it. If I just draw the ideal cycle that we have, that is from 1 to 2 to 3 to 4, and I'm just drawing it. Let us suppose I'm starting from this point. Internally, I'm saying this is 1, this is 2, point number 3, point number 4. Easy. Okay. So this is the cycle that we have ideally. It is 1 to 2 to 3 to 4. Now, what is subcooling basically? Subcooling is a process of cooling the liquid refrigerant below the condensing temperature for a given pressure. So if I do, what I do is, if I cool it towards this side, तो जब वो इस पोर्शन में एंटर करेगा, it will enter into the subcooled region. So if this is 3, this becomes 3 dash up to this point. So from 3, you can draw a line like this. And join it to this point. So this will be your 4 dash and this one will be your 4. Okay, so ideally it is 1, 2, 3, 4. Now it becomes 1 to 2 is same. 3 dash so that it is subcooled, and 4 will be 4 dash now. So this entire region is superheated region, as all of you know, out of this curve. And this region over here represents the subcooled region. So 3 dash जो है आपका पॉइंट वो क्या रिप्रेजेंट करता है? इट रिप्रेजेंट द सबकूल्ड रीजन. तो COP की वैल्यू क्या थी आपके पास? H1 minus H4 ideally upon H2 minus H1 work input. Now it becomes what? The new system, it becomes H1 minus H4 dash now upon H2 minus H1. Now you guys just look at it that the work input remain the same. 1 to 2 is same. Clear? So the work input remains constant. उसकी value change नहीं हो रही है. What is changing? The value of refrigeration effect. So we have to compare H1 minus H4 with H1 dash minus H4 dash. Which one will have more value?
H1 minus H4.
Yes. So this one will have more value. It means overall the refrigeration effect is increasing if we are doing subcooling of it. So what will be the effect of this thing on the COP? COP is what? It is refrigeration effect upon the work input. So it becomes what? COP becomes refrigeration effect is increasing. Work input remains constant. So overall, you can say that the COP of the system will increase if we subcool the refrigerant. Okay. So this is known as subcooling of the refrigerant. So this must be clear to you that if we do subcooling of the refrigerant, what will happen? You will say if we do the subcooling, the COP of the system will increase. Clear? So that is the third very important parameter of